Chandra sir, please unmute yourself. So friends, let me read the biodata of Dr. Ravichander. He graduated in ECE from JNTU Hyderabad, MTech and PhD from JNTU Anantapura. His research interests are wireless sensor networks and brain-computer interface. He has 8 patents and more than 35 research publications. He has completed a UGC-sponsored project and currently ongoing a project, funded project by DST SERP on scientific social responsibility policy. So he's the backbone of this FDP. Here with us, Dr. Ravichander Garu, Associate Professor, Department of ECSR, University Warangal. Welcome you, sir. You can start the session.
Thank you, madam. Thank you, Professor Dr. Usha Desai, madam, for giving me a brief introduction about me. Here once again I'm thanking you. Because of Dr. Usha Desai, madam, only this workshop is possible. This FDP is possible. She has arranged resource persons. Actually, 80% of the resource persons are arranged by her, and everything is taken care. Once again, I'm thanking you, madam. Yes. Now I'm going to start my session. So before I'm going to start the session, just I will give introduction about this FDP. Actually, this FDP is conducted by Department of ECE, SR University, under SERP project, under Scientific Social Responsibility Scheme. We are conducting this FDP, Faculty Development Program. Now I'm going to start the session. Is it visible?
So you can go to presentation mode, sir.
Yes, this one, is it visible? Share. Now is it visible?
Yes, sir. Proceed.
Okay, thank you.
Slide share, go to slide share.
Okay. Thank you. Yes. Here today, my topic is experimental paradigms in brain-computer interface. Here, general way of communication of people or human beings using 5 senses and limb movements. So you see here one person is there. Here he is going to communicate with other people by using his eyes, ears, and lips. Like that, here he is going to use his 5 senses to interact the world. This is the conventional way of interacting the normal people with the entire world. This is the normal scenario or normal way of communication. Now, due to this technology, everything has been changing. Now, the technology is rapidly, day by day, it is going to be changing to help the community or to help the society. So in that way, now the BCI is going to evolve. BCI is going to be evolved because of that reasons. BCI stands for brain computer interfacing. So what we mean by brain computer interfacing means here we are going to control the external devices with our thoughts without physical contacting of any device. We are going to control the external device. That is the meaning of BCI. Here brain computer is an exciting research field that in the future may allow people to control computer using thoughts alone. So with your thoughts, with your thinking, the signals generated by your brain, you are going to control the entire world. You are going to control the devices. World means here it is world means it's filled with a lot of electronic device, computers, electronic devices, electrical device, everything. It is filled with the technology only. Now you are going to control the particular devices using your thoughts. So that is the basic definition for brain computer interface. It is an emerging field. It is an emerging field which allow people to control the computer using thoughts only. So now here the main components of BCI. So these are the main components of the BCI. So here we have a one person. We are going to take the EEG signals from the, we are going to acquire the signals from his brain that will be taken by signal activation step. That is a one major component of the BCI. Then after that feature extraction, then after that feature translation. These all comes under signal processing techniques. Now after that, this after signal processing, that signals will be translated into commands. That commands will be given to the input to the any device. That device will be controlled by using your brain signal. So here the input to the device is your brain signal, and the output is here you are going to control the one particular application. So that is the actual simple definition of the BCI. So here through this here in this particular, if you look at this particular step here, you are going to take the data from here. From data here, how you are going to take by using EEG is you are going to take the data from electroencephalography. So that we have to use to extract the signals. Now for that, after taking that extracting the signal, after we are acquiring that signal, for that we need some methods to acquire that signals. Now I am going to concentrate on that particular methods to acquire that particular signal. That is the major part here I am going to deal today. So that is the signal acquisition step. This signal acquisition step here I am going to discuss today. Then after that we have feature extraction, feature translation and classification. Then we will go for BCI applications. Then that will be given to the feedback to the this device. So these are the major components of the BCI. So here first we are going to take the data from your brain, the brain through EEG. So for that to take the to acquire that through the EEG, so for that we need to do some particular experiments or some paradigms we are going to use. Here some methods we have to follow to implement that. So that's what here we are going to take this. That's what I am going to take this topic, that is paradigms in BCI. So why we have taken this particular topic? What is meant by paradigm actually? Paradigms means here the method of conducting the experiment. The paradigm means it is the method to conduct the particular experiment or method. So it can be implemented using different approaches. In these areas, BCIs are commonly implemented using different approaches called paradigms. So here we have to implement different methods. We have to implement. So that are called as a paradigms. A BCI experimental paradigm is what determines how and what type of data will be recorded, and it gives a blueprint and guidelines the participants of the experiment must follow to successfully finish the experiment. So it is a method to conduct an experiment. BCI paradigms means it is a method or a procedure to conduct an experiment. So that is what we can call it as a paradigm. So now, why we have to discuss about these paradigms? What is the importance of that paradigms? For example, if you purchase one mobile phone, so first here it should be user friendly. If you take our any BCI application, it should be also user friendly, and real time also it should be usable in a simple manner. So that's what these paradigms are very important in a user experience aspect or BCI literacy aspect. Every aspect it is very important. So that's what we have to go for the we have to study about this particular paradigms topic. So major paradigms in easy BCI. What are the major paradigms in BCI? Here, I am going to discuss about the paradigms in the BCI. So there are different paradigms in the BCI. One is ssvp, steady state visually evoked potential. Then after that, here another paradigm is motor imagery, P300. Then hybrid paradigms. A hybrid paradigm means it is the combination of this your motor imagery and P300, or ssvp P300, and then ssvp motor imagery. That is the combination of two or different paradigms are called as a hybrid paradigms. Now, here, what are the BC in that BCI paradigms? One is ssvp, steady state visually evoked potential. Then one is motor imagery paradigm, P300 paradigm, and hybrid paradigms. Just now I discussed that hybrid paradigms means it is the combination of two or more paradigms. Then first I will start with ssvp. ssvp means it is a steady state visually evoked potential. ssvp stands for steady state visually evoked potential. It is the paradigm where each signal is recorded is the direct resultant of the visual stimulus. Here it is the resultant of visual potential. So steady state is an example of paradigm where elements flicker steadily on a screen, where elements are flickered on a screen, but with different frequencies. So this is the paradigm where elements are flickered steadily on a screen, but with different frequencies. When the user focuses on a specific element, the corresponding frequency can become stronger in the EEG originating from the occipital lobe. For SSVP, machine learning can be used to learn classify the distinguish between the flickering frequencies. There are also novel approaches recording no classifier training, but presently we are not providing such. Now, SSVP is the paradigm where the elements flicker steadily on a screen but with different frequencies. When the user focuses on a specific element, the corresponding frequency can become stronger in the EEG originating from the occipital lobe. So that is the SSVP paradigm. Now, the advantages of SSVP paradigm. What are the advantages of SSVP paradigm? Here, the user do not need skill. So there is no need of training or any skill is required for this particular ssvp. That is the major advantage of this particular paradigm. And it is having high accuracy also. It is having high accuracy and precision, time precision and accuracy. And the disadvantages, each and every paradigm is having its advantages as well as disadvantages. Now, the main disadvantage is here it is irritation due to flickering stimulus. For example, if we want to watch that particular screen which is flickering at frequency, normal people they feel irritated. If we conduct experiment on some neurodegenerative people, they will nervous, they will be tired easily. That is the major disadvantage. Why? Because whenever something is flickering, you are constantly observing that flicker frequency. What will happen? You will be tired and you will be nervous. Like that things will be happens. That is the major disadvantage of this particular method. Next, high latency due to dwelling time. So to recognize that particular event, it will take some little bit more amount of time. So that is the major disadvantage of this particular method, ssvp paradigm. Now here I am going to show you one play. I am going to play one video for better understanding. Here you just see here these are flickering. If you want to select one particular thing here, you have to observe this. For example, here it is flickering. Now here it is flickering. First, for example, you want to select B. Then what you have to do? You have to see that B. Always you have to B. So here you just see high. It is used in some speller application. Speller application means high speed BCI. For example, if you want to type high speed BCI, then what you have to do? This particular thing will be flickered with different frequencies. You are going to watch that particular H, then it will flicker with some particular different frequency. Then H will be typed there. Then you have to watch that I will be flicker with a different frequency. That I will be typed there. Then G, then H, like that high speed BCI. So if you want to see, if you want to select H, you have to see which is flickering with a different frequency. If you want to select I, it is flickering with a different frequency. Then if you want to select G, it is flickering with a different frequency. H, they are flickering with the different frequencies. Then that different frequencies that can be generated in the brain, that will be translated into the commands, that will be classified by using machine learning algorithm in the signal processing steps. So this is the normal approach in a BCI. So first, before this classification can be done, what we have to do here, first we have to perform this particular experiment using one paradigm. This paradigm, what paradigm here we are using? We are using steady state visual waveguide potential paradigm, ssvp paradigm. In that ssvp paradigm, each and everything here it is flickered with the different frequencies. That frequencies here you have to observe that are you have to observe that different frequency. When you look at that particular frequency, that frequency is generated in the brain. If you look at another set of thing, you are going to see another frequency. Now here I am going to show you another video which is using virtual reality. Here we are virtual reality using ssvp, steady state visual evoked paradigm. You just see he want to play a game through virtual reality. So he want to blast this particular alien. So this particular alien is here a alien is blinking. So you want to blast that. What he has to do? He has to look at that particular alien. Just see there. This is the flickering. They are flickering. So we have to see that particular alien. When we are kind of constantly watching that particular alien, they are flicker with different frequencies. That frequencies are generated in our brain. That brain signal generated, that will be acquired with the EEG. That EEG generated at different frequencies, that will be classified using different machine learning classification techniques. These are the approach. This is the complete BCA setup. So for that, we have to go for this particular steady state visual evoked potential application. So this is the virtual reality example to explain the ssvp paradigm. In this, here is going to watch this particular, you want to play one game. Okay, you want to play one game. In that, he is going to watch this particular alien. Just he want to blast that alien. Then he has to see that which one is flickering. He has to see that will be flickered. So once he is flickering, that he has to see that particular thing. Then different frequencies will be generated. Once different frequencies generated, that will be blasted. So that's what, without control, using mouse or any keyboard, he is going to play the game. So this is the basic, this is the usage of BCI. Here we are not using conventional techniques, like you are not using your hand movement, you are not using your mouth, you are not using your any senses, you are not using any organs, you are not touching, you are not using your mouse at all also. You are not using anything, you are not using any device. Without using anything, you are controlling your application. So these are the main thing in this particular BCI application. Now, next one is the motor imagery application, motor imagery paradigm. What do you mean by motor imagery paradigm? It is a simple paradigm, is a motor imagery, a simple and real-time paradigm, if we can say. So, motor image is based on the user kinetically imagine some limb movement, such as the movement of right or left hand. He has to continuously think that he is moving his left hand or right hand, like that. He has to imagine himself. He has to, for that we require some little training. So he has to imagine I am opening and closing my hand, or I am moving my left hand, moving my right hand, like that. He has to imagine. When he is imagining continuously, some type of signals will be generated in his brain. That generated signal will be captured, acquired through EEG. That will be classified through a machine learning classification techniques. For that, we require this motor imagery paradigm. That is the usage of this particular motor imagery paradigm. So for that, user should imagine some limb movement, such as a movement of right hand or left hand. The user should imagine the sensation of the movement also. Then after that, classifiers will be trained to detect the difference in spectral band powers. So that is the motor imagery paradigm. So here, each and every paradigm is his own advantage as well as disadvantage. Based on the application, based on the usage, we are going to select the paradigms. So each and every paradigms is having its own advantages as well as disadvantages. So the main advantages of the BCA, this motor imagery paradigm is, here it is less time taking in terms of training. There is no training required for this particular motor imagery paradigm. And it does not need any stimulus. It does not require any flickering. So when we flicker, that user may confuse, or he may be irritated, he may be disgusted, or he may be fatigued, like that. So many problems will come. So here that type of problems we can avoid with this particular motor imagery paradigm. Motor imagery paradigm does not need any flickers or flashes. So that is the main advantage of this particular motor imagery paradigm. And it is less sensitive to timing rather than P300. So that means here it is faster. It is somewhat faster. That is, response is faster than this one, P300. It provides more realistic approach. It is very simple. In real time, always we may not provide some flicker in front of a person, that will be flicker. It may not be possible every time. It is not user friendly also, like ssvp. So here just simply our user just simply imagine something. You want to do that movement of his left hand, or movement of his right hand, or movement of his some legs, or opening and closing of his left hands, like that. He can imagine that. For that, there is no specific device required. Just a user can imagine himself. So that's what here it is a user friendly and it is a realistic approach to BCI as a classification of imagery of multiple body parts. Now, here the disadvantage of motor imagery is a high latency due to dwelling time. It is somewhat high latency. Now, here motor imagery. Here, this is the gestures of motor imagery, like left hand, right hand, left foot, right foot. The user instructed to imagine movement of left hand, movement of right hand, movement of left foot, movement of right foot, or opening and closing of left hand, opening and closing of right hand, opening and closing of left foot, like that. You can or movement to the left side or movement to the right side, like that. Based on that, we can design our applications. So that is the thing here we can do with this particular motor imagery application. Now here I am going to play one video. Here the user is instructed to imagine of his left hand or right hand. Just user is instructed to, he is thinking that I'm left hand is I'm opening and closing left hand, left hand, left hand. That means he's this one is moving from here to here. Our user is this instructed to think or imagine is moving his right hand like this up to this particular time. So your this one will be moving from here to here. Whenever he is thinking up to this time, that particular thing will be moved. So whenever he is thinking from here to here, then the user is just imagine that here your target here up to 5, your target will be up to 5. Then user is imagine that here his right hand is opening and closing, is imagining that is opening is closing right hand up to 5, up to reaches to the 5. Then based on that instruction, he has to perform the experiment. So this is the motor imagery pattern. Once again I will play this video. Now, user is instructed to imagine right movement of right hand up to target 2. Let us take 2. Then he is imagining up to 2. Then here it will be movement up to 2. Then target will be 3. Then he is imagining that he is movement is opening and closing up to 3. Then here, in the next case, the target will be 4. Then he is imagining up to target 4. Open, close, open, close. Now, if the target is, then he stops imagining. So that's what, whenever he stops the imagining, this will be stopped. Now, his target will be 5. Up to reaches target 5, he has to imagine that he has to opening his right hand, opening and closing, like that he has to imagine. So this is the motor imagery pattern. This is the example of a motor imagery pattern. Now, here you just have seen, I've heard one beautiful music that, piano sound. Now, this is one example of wheelchair, controlling of wheelchair using motor imagery pad. So here, how is thinking that he is moving, you want to move to the right side. Then what he has to imagine is imagining that he is moving his right hand movement. Is moving his right hand movement. His right hand should be thinking that his right hand should be moving. Right hand should be moving like that. Yes. Next, left hand means left side. If you want to move to the left, then he has to imagine that his left hand should move. He has to opening or closing, or is imagining. Just I am anything. Just he has to imagine that he has to moving his left hand like that based on our instructions. Next, you want to go straight. If you want to go to straight like that, he's that right leg should be moving. Right leg should be moving like that. You can imagine. So based on our instruction. Actually, this video is playing very fast, but in a real-time situation, it is not this much fast. Just they speed up the video. Just once again look at this video. Yes. So this is the one good example for motor imagery paradigm. Here is a neurodegenerative person, and he cannot walk and he cannot move. So he is sit in the chair. He want to move from one place to another place. For that, he has to think, moving off his left hand, moving off his right hand, moving off his leg. Like that, he can think and he can move from one place to another place. These all things are possible because of brain computer interfacing. Now next, another one is the P300, which is the P300. It is a P300 is a another next paradigm. It is in the P300 paradigm. The user is requested to focus on something. In the P300 paradigm, the user is requested to focus on something like a specific letter on a screen. When a letter will be on the screen, he is instructed to focus on that particular letter. Then, or a specific sound also. When a letter is suddenly highlighted or focused event occurs, a specific weak ESG pattern can be detectable approximately 3 milliseconds after. So whenever that particular letter is highlighted, then one particular type of peak signal will be generated on the brain. So that will be detectable. So repeating. So this is the P300 signal. P300 is a positive deflection in the signal after about 300 milliseconds presentation of the stimulus. So now P300 is mostly oddball paradigm. Oddball paradigm means here whenever the something is uneven is occurring. For example, here I am looking to one particular thing. Now it is for certain amount of time nothing is happening. Once something is happening that is uneven, so then what will happen here? One particular type of signal will be generated. For example, just here for example, you just see here I am changing my slide. What happened? One particular spike will be generated. That is uneven. I am looking at my current continuously. I am looking to particular situation or particular target, but my brain is that time my brain signal will be flat. But whenever one particular thing suddenly there is a change in the slide, or suddenly there is a color change will be happen, then what will happen? There will be a different signal spike generated in the brain. Due to that, P300 signal will be generated with 300 milliseconds duration. That is the P300 approach, which is the main thing in this one will be oddball paradigm. Now, the advantage of P300 is high accuracy. And training is not required for this. These are the major advantages of P300. P300 is high accuracy and It is not required any training. These are the main. So if you want to go for multiple selections, if you want to go for multiple selections, good number of multiple selections. So, but that is not possible in the case of ssvp or motor imagery. Motor imagery means you can imagine two or three things like that. Multiple selections may not be possible with motor imagery. But in P300 case, you can multiple selections, more number of selections are required. That time you can select this type of pad. That are the another advantage of this P300 pad. And regarding this disadvantage, it is a time consuming pad. So you have to look at that particular screen continuously. Then that some odd things should happen. Then after that, that odd thing should be captured by your brain. That will be acquired through EEG. That spike will be generated in the brain. That will be acquired through EEG. So this is something. It is not fast. Something it is not a fast method. So that is a major disadvantage of this particular thing. And one more thing is repetitions. We have to repeat the experiments sometimes like that. That is also another. Now another disadvantage is signal processing also very sensitive. Why? Because that spike, the detection of that spike is also very difficult. So that's what we have to remove. Which one is noise, which one is that things we have to remove. Now we just look at this P300 here. Here in the P300 experiment, what will happen? This one will be this particular. First, this column will be blinking. This column will be highlighted, not blinking, sorry. Here this column will be highlighted. Next, after that, this row will be highlighted. For example, if you want to select P, if you want to select P, then what you are going to do here, you are going to see that particular P. Whenever this row and column will be highlighted, then that particular time your brain signal will be generated. P300 potential signal will be generated or evoked. Here P300 it will be evoked in your brain. So that is the P300 signal will be generated. So these things here, it will be faster. This will be faster changing. It will not be some with the faster duration. It will be changing. This highlighted, these colors will be changing faster. This one and this one like this. It is going to be changing fastly. So whenever you select this here, it will be if you want to select this, you have to, for example, P. If you want to select P, you have to look at this particular P. Then whenever then this particular column P, then after that row also highlighted. Once row is highlighted here, then your P will be selected. So in that speller and some application, you can use this. Now just look at this video. In this, you want to look at Europe. This is the world map. You want to look at the Europe. So there are here, Europe is here. For example, Europe is here. He's looking at here. Yes. Once he is looking at here, the once the color will be changed, then after that, you want to select the London. From that, so if you want to select, first you want to select the Europe. This particular person want to select the Europe. From that, you want to go to London in the world map. So first he has to look at one particular screen. In that one, you want to choose one box which is at Europe. So he is to see this particular thing continuously. He has to see. Once the color will change, then that will be selected. Then Europe is selected. Then you want to go to London. Then in that, he has to select this. Now is watching the London. So that is the thing. That is the experimental P300 pad. Now he want to see North America, then he has to see another selection. Like that, he can choose anything. So this is the P300 paradigm example. Now this is also another example. Here you just look at this one. Just see these instructions. Now here, using this P300 paradigm, this robot is controlled. Now here, the user want to sit in front of this particular GUI. He has to look at objects. For example, if you want to select, if you want to look at the table, if you want to move that particular table, he has to continuously look at that particular table. He has to continuously, this is he has to continuously, that command he want to give that, go to the table, to the robot. He has to continuously look at that table. Then he look at that. Then what is happening? This robot is moving towards the table. Then that happened. Just see. So he's looking at that particular robo, that table. Then next you want to pour this. You want to this fill this glass with a bottle, drink. So then he has to look at these two things: water, this bottle, and this particular uh, glass. This bottle and glass, he has to look at the two things. He has to select. Now he is to select the action to be located. So he has to see this one and this one, then this bottle and this glass. Now just see. So he has to see. Then the P300 is generated. Then that will be given to this particular robot as a command. Then this bottle ring will be poured into this particular glass. So it is mixed. Then that is the action can be performed. So these, all these things are possible with this type of paradigms. Now hybrid means it is a combination of two or more paradigms. It is a hybrid paradigms means it is a combination of two or more paradigms are called as hybrid paradigms. Now, typically used to do more complex tasks in a less time. So, to do complex tasks in a less time, we have to use this particular hybrid paradigms. Now, hybrid BCI paradigms provide better accuracy. The accuracy is definitely increased because of these paradigms. Now, it can be used in more complex tasks, more bigger tasks. We can use this particular paradigms. Hybrid BCI paradigms are more confusing and difficult to train than individual paradigms of the hybrid. These hybrid BCI paradigms are more confusing and difficult. That is the disadvantage. Why? Because performing only one experiment is a little bit confusing to the user. Then mixing this ssvp and p300, how it is difficult. So that is the main disadvantages. Training of the people, and they have to perform that particular experiment correctly, and they have to follow the instructions correctly. Like that, it is very difficult and complex also. So that is the main disadvantage of this particular paradigm. Now here you just see. Here it is the combination of ssvp and p300 paradigm. You just see here it is flickering, as well as here it can be the color is also going to be changing. Here it is a speller example. Here you want to type with speed, you want to select with speed. Then what you are going to do here, it is flickering with different frequencies. And as well as you can select color that particular thing by using this particular p300. Why? Because there is a oddball paradigm. So that is going to be changing. Your color is also going to be changed from one thing to another thing. So the two things, two paradigms are combined in this particular speller application. So this is the hybrid paradigms. So why we have to provide more selections, and more accuracy, and to do more complex actions, we have to go for this particular hybrid paradigms. Otherwise, we can go for simple paradigms that are easy and user friendly also. But if we go for more complex things, then we have to combine this ssvp and p300 paradigms. So this is regarding different paradigms. The what we have discussed now, there are three more majorly. There are four paradigms are there. One is ssvp, steady state visual vehicle potential paradigm. Then after that, motor imagery paradigm. Then after that, p300 paradigm. Then hybrid paradigms. Each and every paradigm is having its advantages as well as disadvantages. Based on the applications, we can use these paradigms. Based on the applications and requirements and your need, you have to choose that particular paradigms. And regarding this here we have published some papers regarding this EEG BCI paradigms, that is recently published in the Springer. That is advances in experimental paradigms for EEG BCI in Springer. It is published by with me and Rakesh Sen Gupta, Vishwas Dalal, my junior research fellow. So actually, this workshop is conducted by Department of ECE, but it is sponsored by DST Servo under scientific social responsibility. We have sanctioned one project. That is, we have sponsored one project under that. That is a hybrid EEG BCI for web interface navigation. A novel hybrid BCI web interface navigation. The project is sanctioned. Under that scheme, under that project only, we are conducting this particular FDP. So that one only we are doing this experiment, and we purchased a EEG machine, which is 64 channel EEG machine, and we recently we have purchased one device that is emotive, and we have purchased eye trackers. We have two eye trackers are there to conduct experiments. In the hybrid paradigms, just now what I have discussed, we can combine this normal this P300 and ssvp paradigms with the eye tracker also. We can combine that eye tracker as well as with it. That is also called as hybrid paradigms. Now, progression of another paper we have published, there is progression of EEG BCI classification techniques study. Me, Rakesh Sen Gupta, and Vishwas Dalal, and Rashekar. Then signal processing algorithms based on evolutionary optimization techniques in the BCI. These are the publications. Various signal used for device navigation in BCI production. UAN EEG BCI classification techniques advancements. Next, advances in modern EEG BCI signal processing review. This is the materials today proceedings. Now, recently we have published one in journal, that is NanoLife, towards a more theory-driven BCI using source reconstructed dynamics of EEG time series. In this, we are going to use source localization techniques to find the particular things. Now, these are the things I want to share with you. Actually, I am the new to this field. From just 2.5 years only, I have started working on this field. So I'm new to this field. Okay, maybe I have shared my experiences with you. Thank you for giving me this opportunity, Dr. Usha Desai, Madam, organizing committee of EC department, and Rakesh Sen Gupta. All I am going to thank everyone and my